Hi friends, in this session of probability we study about the terminology what we use in probability. So first of all, I explain you what is probability, a numerical measure of likelihood of occurrence of an uncertain event is called the probability. So numerical measure, how we measure it. So I have explained you our earlier lectures. So what is the probability? So I again write down here. Probability is equal to favorable outcome over total outcomes. See, you already know that this all what is favorable outcome. It means the number of outcomes which result in happening of your desired events are called favorable outcomes. So look at here, if we throw a coin, or we have two outcomes in a coin. Throwing a coin, we get only sample space if we see head and tail. So if I bet on head, so my favorable outcome is only one, which is head only. So this is called the favorable outcome, and the total outcomes we have two. So the probability of getting head is 1 over 2, because the total outcome is 2 and the favorable outcome is 1. So this is all about the probability. And now I explain you what is random experiment. Whenever you study the statistics or the probability, you always see the random experiment and random experiment. So I explain what is random experiment. So it is an experiment which, if conducted repeatedly under homogeneous conditions, does not give the same result. The result may be one of the various possible outcomes. So look at here, if we throw a dice, we get the outcomes like this: 1, 2, 3, 4, 5, 6, up to 6. But we can't say always we get 4, that this time we get 3. We could get any outcome, any particular outcome randomly. So that is not in our hand. It comes randomly because we are conducting this experiment in homogeneous condition. Okay, so in this way we could get, if I throw a dice, so I get any number in this way. Look at here, it may be any one of these. So if I get 3, so it is the probability of getting a number. I am getting here 3, the probability is 1 by 6. So getting any outcome, the probability of getting any outcome is 1 over probability of getting any number here is 1 over 6. So in this way you could get here. Now I explain you about the trial and event. Look at here, the performance of random experiment is called trial, and the outcomes an event. Now if we are tossing a coin, it is called a trial. The tossing is trial, and the getting the result, head or tail, whatever we get, is called the event. So look at here in this picture. Now the simple and compound event. An event is called simple if it corresponds to a single possible outcomes. So look at here, thus in tossing a dice, the chance of getting 3 is a simple event, because 3 occurs in the dice only once. We know that the outcomes 1, 2, 3, 4, 5, 6, 3 is only once there. So the probability of getting 3, is 1 over 6. However, the chance of getting an odd number is more than 1, because we have 1 odd number, 3 odd number, 5 odd number in the dice. So we have 3 favorable outcomes. So where the outcomes are more than 1, then these are called the compound event. So the probability of getting an odd number is 3 over 6, which is 1 over 2. So this is the compound event, and this is the simple event. Okay. Now the next one, exhaustive cases. All possible outcomes of an event are known as exhaustive cases. If we throw a dice, so the possible outcomes we get here, the sample space 1, 2, 3, 4, 5 and 6. These are all sample space. These are all the total outcomes we have written here. These are all the possible outcomes also. So these make the exhaustive case. If we add the probability of each, we get always 1. If you have to find out the probability of any number, you want to get any number, then you if you want to know the probability of getting 1, so if you want to know the probability of getting 1, it is 1 over 6. If you want to know the probability of getting 2, it is, we have only 1 2 here, so it is also 1 by 6. Getting 3 is also 1 by 6, then 4 1 by 6, and 5 1 by 6, and finally 6 also 1 by 6. So if we add it up, so the 6 we are taking common, and the numerator you get 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6. So we always get 1 in exhaustive cases. The total, the sum of all the cases is 1. Now the favorable case. The numbers of outcomes will result in happening of a desired event called the favorable case. As I explained you earlier in the probability definition, I explained you, if we are tossing coin and the sample space, we know that head and tail. Now we have to find out the probability of getting head. Probability of getting head. Head is only 1. So we have one favorable case here. Okay, 1 over 2. So there is only one favorable case, which is head. Now the mutually exclusive cases. Now I would like to explain you about the mutually exclusive cases. 2 or more cases are said to be mutually exclusive cases if the happening of any one of them excludes the happening of the other cases in a single experiment. If we have a dice, we are throwing a dice, or we want to know the probability of getting an even number. So probability of getting an even number is equal to, we have even numbers 2, 4, 6. So we have 3 favorable outcome and 6 total outcomes. So, and we have another case, we see probability of getting an odd number. Odd number we have 1, 3, 5. So which is also 3 over 6. So the probability of getting an even number, if you see the sample space, I write down here, the sample space for this 1, 2, 3, 4, 5, 6. The even number I explained here again, the even number is 2, 4 and 6. And if you see this odd number, that is 1, 3 and 5. So mutually exclusive cases, both the cases are mutually exclusive. There is no intersection between both the cases. 2 or more cases are said to be mutually exclusive cases if the happening of any one of them excludes the happening of other cases in a single experiment. So look at here, these are the mutually exclusive cases. Similarly, we could see in the coin case also. If we are going to toss a coin, so getting the head and the tail, so these are also mutually exclusive cases. Now equally likely cases. 2 or more events are called equally likely if the chances of their happening is good. Here, look at here also in the previous example, as we have seen, the probability of both the cases is, here is also 1 by 2, here is also 1 by 2. So happening, the chance of happening both the events are equal. So these are all equally likely cases, 1 by 2, 1 by 2. Similarly, we could use in the coin also, probability of getting head, probability of getting head, which is 1 over 2, probability of getting tail, which is also 1 over 2. So 2 or more events are called likely, equally likely if the chance of their happening is equal. The chance of their happening is equal, 1 by 2, 1 by 2, their probabilities we have. Now look at independent and dependent event. An event is said to be independent if its happening is not affected by the happening of other events, and if it does not affect the happening of other events. So look at first I explain about the independent event. Now here, for explaining the independent and dependent event, we use two questions for better explanation. From a well shuffled deck, we withdraw a card and put it in the deck and then withdraw another card. It means with replacement. What is the probability that both cards are king? So we see A is the event of getting the first card as king. So probability of king getting a king, P of A, and we have 4 kings in a deck of 52 cards, so it is 4 over 52, it means 1 over 13. Now another event, we are withdrawing another card after replacement. So we have again 4 kings, we have again 52 cards, so probability of B is again 4 over 52, it would be same. So now we have to find out the probability that both cards are king. So probability of getting a king, both cards are king, A intersection B. It means we have to use the multiplication approach here for probability. I will explain you in detail in our successive sessions. So in the multiplication, we have to multiply the probability of both the events, P of A into P of B. So P of A is 1 over 13. It is also 1 over 13. It means 1 over 169. So this is the probability of getting both the cards are king. Whereas dependent events are those in which the occurrence or non-occurrence of an event in any one trial affects the probability of other events in other trials. So let us see. And now in the second question, you see from well shuffled deck we draw 2 cards successively without replacement. What is the probability both cards are king? So we are not replacing the card again in the deck. So here you look at here, the probability that the first card be king is A, P of A, which is 4 over 52. Now we have withdrawn one card, we have not replaced it. Now if it is king, now we have only 3 kings in the deck and the total number of cards are 51. So probability of B over A is 3 over 51. Now we have to find the probability of in this way we could get that the probability of A intersection B, which is probability of A into probability of P over A. So finally we get probability of A is 4 over 52, it is 3 over 51. If we simplify this, we get here it is 1 over 13, here 3 1 times, 3 17 times. So 1 over, sorry, I changed the color, it is 1 over 13 into 1 over 17. So finally we get here which is 1 over 121. So this is finally we get here the probability of getting that both the cards are king. So here you see the difference between the independent and dependent event. In the first question we have seen the independent event and the second question we have seen the dependent event. But the second event is dependent on first event. If we are getting the king, then the chance of getting the king in the second event would be less. Okay, so in this way we get this thing. Now complementary events, if there are two events such that they are mutually exclusive as well as exhaustive or complementary events. So I explain you, if we have a coin and we have the sample space of coin, sample space of coin is head and tail. So getting a head, probability of getting a head is 1 over 2, probability of getting tail is also 1 over 2. If there are two events such that they are mutually exclusive, both the events are mutually exclusive, because if we are getting head, then it means we are not getting tail. If we are getting tail, it means we are not getting head. As well as if we add both the events, in this both the events you get all the all the possible outcomes we have got in both the events. The head is here and the tail is here. So if we add this, P of H plus P of T. So we get here P of H, we know that it is 1 by 2, P of T is also 1 by 2, we are getting 1. 1 is the maximum possibility or the probability of an event. So if we are getting it 1, it means these are the exhaustive, both the events are mutually exclusive. We know that both the events are exhaustive. Here we are saying that, so both the events are complementary of each other. It means P of H is equal to 1 minus P of T, both complementary of each other. If we subtract an event from 1, we get the probability of other event. Okay, it means if we subtract the probability of event from 1, we get the probability of other events. So these are called the complementary events. Thank you.